Right, by looking at question 7, it says two people standing respectively at A and B see a helicopter H hovering 250 meters directly above C. The angles of elevation of A and B respectively to H is 26,6 and 21,8. A, B, and C are in the same horizontal plane. Calculate the distance between the observers AB. Now, 1 mark is allocated for the correct ratio. The tan of 21,8 degrees is 250 over CB. 1 mark for the value of CB, which is 625,0555906 meters. Another mark is for the correct ratio of the tan of 26,8 degrees is equal to 250 over AC. 1 mark for the value of AC, which is 499,2384639 meters. Then 1 mark is for the correct substitution into the cos rule. That means AC squared plus BC squared minus 2AC times CB, the cos of the included angle, which is 104,5. AC squared is 499,23, etc. squared. CB is 625,04, etc. squared. And yeah, again, you substitute your A and your CB value. And then 1 mark is for the answer of AB, which is 892,29 meters. Okay. Then the next one, in 7.2, they say calculate CBA. Here we've got to calculate CBA. We've got to calculate this angle. Yeah. So in this case, we can say 1 for the correct sine rule. The sine of CBA over AC is equal to the sine of ACB over AB. 1 for the correct substitution. The sine of CBA over the AC, which is 499,238, etc. The sine of ACB is the sine of 104,5 degrees. And the AB, which is given as 829,29. And then 1 mark for the answer of CBA equal to 35,65 degrees. That is your third mark. If we look at question 8, in question 8 we have got the following diagram. In the diagram below, PQR is a tangent to the circle with ST parallel to QW, and VT is equal to VW. VT is equal to VW. SWQ is 70, that's 70 there, and WQR is equal to 30 degrees here. Now S1 is equal to 70 degrees, right? And the reason here is alternate angles. Okay, so let's quickly have a look at the following. We say S1 equal to 70 degrees, 1 mark for the answer of alternate angles because ST is parallel to QW. 1 mark for the reason. The reason stating alternate angles and which lines are parallel. 1 mark for that. Now we have to determine the value of ST. ST is equal to 30 degrees, 1 mark for that. The 8.3, we get to determine the values of Q1. Now Q1 is equal to 70 degrees and 1 mark for the reason, which is the tan chord, angle between the tangent and the chord, or tan chord theorem. The Q2 is equal to 80 degrees, 1 mark for that statement. And 8.4, V is equal to 110, 1 mark for the reason, which is opposite angles of a cyclic quad. And 8.5, W1 is equal to 35 degrees, angles opposite equal sides. 1 mark for saying angles opposite equal sides. 1 mark for the reason. And in 8.6, we say W2 is equal to 80 degrees, 1 mark for that statement. And the reason is sum of angles of a triangle, 1 mark for 80 degrees in this specific case. Right. If we look at question 9, in question 9 says, use the diagram to prove that the angle between the tangent and the chord is equal to the angle in the alternate segment. We had to prove that that there is equal to that there. Right. So let's look at the proof. Now just remember that because it's a theorem proof, if there's no construction, in this case 0 marks, you cannot just write something and expect marks. No construction, 0 marks. Okay, what is given in this is tangent FCG is given. Required to prove that angle C2 is equal to angle A2. And the proof is draw diameter DC and join DA. 1 mark for that construction. Now we can say that C1 plus C2 is 90 degrees, that the tangent is perpendicular to the radius. 1 mark for that statement and the reason. Now we can say that angle A1 plus A2 is 90 degrees, and that is angles in a semicircle. 1 mark for making the statement, A1 plus A2 is 90 degrees, and 1 mark for the reason, angles in a semicircle. Now, in this case, we can say that angle A1 is equal to, in this case, angle C2, because BD subtends equal angles. So 1 mark for the statement of A1 equal to C1, and 1 mark for the reason BD subtends equal angles, and therefore we can conclude that if C1 plus C2 is equal to 90 degrees and A1 plus A2 is equal to 90 degrees, but this C1 is equal to A1, right, because of that reason, therefore A2 must equal to C2, and that is what we're supposed to prove. So 1 mark for construction, 1 mark for this statement and reason, 1 mark for this statement, 1 mark for this reason, and then once again 1 mark for saying that A1 is equal to C1 for the statement and 1 mark for the reason. That will give you 6 marks for this proof. Right, in question 9.2.1, they say 2 circles that touch a D are drawn below. GI is a tangent to the smaller circle. GI lengthened meets CB at A. IG lengthened cuts the bigger circle at F. That HD is a common tangent, and what we had to add to this is that CDG is a straight line. Now CDG is a straight line. That is something that needed to be added to the question. Now we've got to show that GE is parallel to BC and that HI is equal to HD. Right. We can start off by saying that D8 is equal to B1, the tan chord theorem, or angle between the tangent and the chord. 1 mark for statement, 1 mark for reason. 1 mark for saying that D4 is equal to E1, 1 mark for the reason, the angle between the tangent and the chord, or tan chord theorem. So 1 mark is for that statement and reason. Here we get a mark for statement, reason, and here for statement and reason, 1 mark. And then 1 mark to say that D4 is equal to D8, vertically opposite, 1 mark for statement, 1 mark for the reason. And therefore, B1 is equal to E1, that is a deduction. And because B1 is equal to E1, therefore GE is parallel to BC. That means if alternate angles exist, the lines are parallel, the converse of alternate angles. Right, so that reason there is another mark. So allocation of 6 is statement 1 mark, reason 1 mark. Statement and reason 1 mark, statement 1 mark, reason 1 mark, and then to say that the lines are parallel because alternate angles exist. Right, in 9.2.2, 1 mark, we had to show that HI is equal to HD, 1 mark to say that I1 is equal to C2, and this is the tan chord theorem, 1 mark for statement and reason. In this case here, we can say that D5 is equal to C2, tan chord theorem, 1 mark for statement and reason. And therefore, if R1 is equal to C2 and C2 is equal to D5, then R1 is equal to D5. And if R1 is equal to D5, then we can say sides opposite equal angles, therefore HI is equal to ID. That is 1 mark for your reason. Right, in the last question, question 10. Right, in 10.1, they say QS is parallel to BC. They say the area of triangle AQS is equal to the area of triangle QBCS, and ARP is perpendicular to BC. And what you need to add here is that QS is equal to half of BC. Now your first question is to prove that triangle AQS is similar to triangle ABC. So in this case we can say angle A equal to angle A, common, 1 mark for statement and the reason. In this case here, O is equal to angle B, corresponding angles because QS is parallel to BC, 1 mark for the statement and the reason. And in this case, angle C is equal to angle S, corresponding angles because Q is parallel to BC, 1 mark for the statement and the reason. And therefore triangle AQS is similar to triangle ABC because of angle, 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 1 mark for the reason, angle, angle, angle. So 1 mark for statement and reason, 1 mark for statement and reason, 1 mark for statement and reason, 1 mark for reason, angle, angle, angle. Right, in 10.2, prove that AR divided by AP is equal to QS divided by BC. Now, from this, we can deduce that AQ over AB is equal to QS over BC is equal to AS over AC. Because this can be read off because the two triangles are similar, which are proved there. Similarly, we can say that AQR is similar to angle ARP because of angle, 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 1 mark for statement and the reason. And then we can make a statement. From there, we give 1 mark for the statement. AQ over AB is equal to QR over BP is equal to AR divided by AP, 1 mark for that statement. And because, in this case, that AQ over AB is equal, because AQ over AB is equal to QS over BC, and AQ over AB is equal to AR over AP. Therefore, we can say that QS over BC is equal to AR over AP because they're both equal to AQ divided by AB. So 1 mark for statement and reason, 1 mark for this statement and the reason, and then we can say, in this case, just for that statement, we give another mark. In the last one, in 10.3, we're going to show that AQ divided by AB is equal to 3. Now, the area of triangle AQS is half AR times QS, and the area of the trapezium is half QS plus BC times RP. So now if we divide AR, to divide this both sides by RP, so it's AR over RP, divide both sides by half QS, is equal to a half QS plus BC over half of QS. Halves cancel out, so it gives you QS plus BC over QS. Now, it tells you that QS is half BC, so BC is twice QS. 1 mark for that statement. So you're going to get 1 mark for the area of triangle ABC, the 1 mark for the area of triangle that, 1 mark for the ratios, 1 mark for the statement that QS is equal to twice BC. Therefore, we can say that AR over RP, right, is equal to AQ over AB, statement and the reason. That's proven. And therefore, if AQ over QB or QB over AP is equal to AR over RP, but AR over RP is QS plus BC over QS, but BC is equal to twice QS, as QS plus 2QS over QS, which is 3QS over QS, which is equal to 3. 1 mark for the area of the triangle, 1 mark for the area of the trapezium, 1 mark for the ratios, 1 mark for the statement and the reason, 1 mark for the statement and the reason, and 1 mark for, to get BC in terms of QS, 1 mark for rewriting it there, and therefore we have shown that it's equal to 3. 10.3 is equal to 6 marks. The question altogether is 13 marks. This brings us to the end of the memo discussion for grade 12.